so we're going to start with some setup stuff to start with. So if you go and you pull out your tablet and you go to My Notre Dame and you scroll down to the link section, we're going to do our Delta Math registration for this semester. So since all the classes got different people in them, we have to do this again. So go ahead and just click the link for Delta Math registration. And that should take you straight through, what's it going to look like? So it should put you here and fill in the passcode or the registration code automatically for you. Just hit register with Google. And then basically you're done. Right? It should if you go from the link. No. If you just do the link, the code will automatically be there for you for this semester section, and you just hit register with Google and you're done. Well, you have to like pick your Google account or whatever, you have to do that crap, but it's like 10 seconds. Okay. Yep, the one that says registration. And that link will disappear next week or something. It's only here for a little while, so it won't confuse you later on. Yep, the passcode should automatically be there for you. After you've done that, pull up your Microsoft Teams for me. Yep, Teams. This is the only time we use it. But once you've finished your Delta Math registration, open up Microsoft Teams. And you should find a tile for third hour pre-calc. Does anyone not see that? Anyone missing their third hour pre-calc tile? Okay, so go ahead and click that. Click the tile. And then from this navigation pane on the left, you'll pick Class Notebook. It'll take a minute for your OneNote to load in for you. But once it does, up here in the inside of the OneNote browser, instead of say open in browser, pick the open in desktop option. And that'll open up your OneNote for you automatically and connect your OneNote to the shared OneNote notebook that I made for you guys, and you're done. No more Teams anymore. Did anybody have problems with that? Same procedure we did at the beginning of the year, so at least it should be kind of familiar. Okay. So Brett, most of the stuff that I do, I'm using OneNote. So this is where all the notes will be at and all the assignments, if they're a document assignment. This is the way we'll turn in homework. So it'll all be done inside of OneNote. If you have questions about stuff, holler or ask one of your friends that are nearby. This is what we've done all semester, so everybody other than you should be well practiced on this. So if you have problems, holler. All right. Okay. The syllabus is the same thing that we saw first semester. So it's the same grade distributions, the same things on all this stuff. The only part that changed was the stuff that we're going to be doing. But otherwise, it's all identical to what we saw first semester. Again, I'm not going to go through all this stuff right now. Brett, take a quick cruise through it at your leisure. Boyd?
It's just a blank page when I click in class, so I can't find it.
All right. So this just doesn't fill in for you? Okay. And you're in third hour for pre-calc?
Yeah.
Let's look real quick here. Okay, you're there. Shows you logged in. Okay. Gosh, go away. We'll take a look at that in a minute here, Boyd. See, you think you got it? Oh, okay. That's always a decent idea there to start. Anyways, so the syllabus is here. If you want to come back and look at it again, that's fine. Or if you wanted to look, it's in My Notre Dame also. Same thing both places. I would say Brett, I think you're the only one that didn't do the sign-in sheet from during first semester. So when you have a minute, download that, fill it out, have your parent or guardian sign it with you, and then just bring it back to me sometime. Or you can dump it in your OneNote. That's fine too. Do it all digitally is fine.
Browse, you see that? Click the arrow. Click it to the top. Then click the arrow, and it should be open in desktop.
Okay. So we got seats. We got Delta Math set up. We got OneNote set up. I think we're good to start then, right? So we're going to be starting with Bree. Sure. We're going to be starting in chapter 7 then. Which is a good one to start with because it's pretty easy, which is a nice. Oh, come on, you jerk. Sure. All right. So today we're going to be talking about the law of sines, and then next time we'll talk about the law of cosines. So we saw in first semester that if we wanted to solve a right triangle, we can do this using SOHCAHTOA, right? If I want to find all the side lengths and angle measures in a right triangle, I can just use my SOHCAHTOA definition for sine, cosine, tangent, and I can accomplish that. The question should be then, well, what about all the other triangles? Because a right triangle is kind of a special case. What do I do if I have some non-specific triangle? So let's just say that we have some non-right triangle ABC with side lengths A, B, and C. Right? Remember that our convention for naming triangles is if we typically use a capital letter to name the vertices, and then the side opposite that vertice is named with the lowercase letter. That's kind of our convention. So let's just say we have some non-right triangle. And my goal here is I want to try to solve this right triangle. So what I'm going to do is I'm going to start by just kind of drawing in an altitude from one of the vertices. It doesn't really matter which vertex I choose. I'm going to choose to draw my altitude from C. And remember, an altitude is a segment inside of a triangle where the one endpoint is a vertex and the other endpoint is perpendicular to the side opposite the vertex. And I'm going to say that the length for that altitude is h. Now, what's nice about this altitude is it's created two right triangles for me. It's created the right triangle I don't have another name for it. I don't really need that right triangle. And it's also created for me that right triangle. Everybody cool there? Okay. And inside a right triangle, I can use SOHCAHTOA. So I can say that in the yellow triangle, sine A is going to equal opposite over hypotenuse. And in the green triangle, I could say sine B is equal to opposite over hypotenuse. And both of those two things need to be true. Is that okay? I notice inside of these two equations that I've just written that are both true, they both contain h. So what I'm going to do is I'm going to get the h by themselves so I can set these two equations equal to each other. So for my first equation, I'm going to multiply both sides by b. And in the second equation, I'll multiply both sides by a. So when I put those two together, say that. Everybody feels good? And if I divide both sides by AB, over here the b's would cancel, leaving me with sine A over A, and over there the A's would cancel, leaving me with sine B over B. Everybody's okay with that? And if I wanted to, I could then repeat this process, but instead of drawing my altitude from C, I could draw my altitude from either A or B. And doing that would get me this third part. And this right here is my law of sines. Did you get it, Bree?
Yeah, I got that.
Okay, no problem. You should have hollered at me that you're having a problem before.
Yeah, I thought it worked, but then it didn't.
Oh, okay. That happens. All right. So let's do an example where we're using this law of sines to solve a problem. So again, the directions say in a triangle where A is 32 degrees, B is 73 degrees, and C is 13 inches. Solve the triangle. When we say solve the triangle, what does that really mean for us? It means we need to find angle C, we need to find side A, and we need to find side B. The other three measurements. Feel good to you guys? So my first step would be to draw a picture and label our picture. So I'm just going to use the figure that I had already on hand. So A is 32 degrees, B is 73 degrees, and side C is 13 inches. So which one should we solve for first? There is a right answer to this. There's something we need to do first. Brett? We got to find angle C first. The reason is to be able to use the law of sines, I need to either know both angle C and side C, or angle B and side B, or angle A and side A. I don't know from the given information two of any of them, right? Everybody see that? So we need to find angle C first, and we can do that pretty easily. How can I find angle C? I don't need to use any trigonometry to do this. This is just geometry to find angle C. Caden?
And the angles.
Yeah, great. I know that the sum of the interior angles for a triangle is 180 degrees. Very good. So I know that angle C is just going to be 180 minus 32 minus 73. So that gives me 75 degrees. Everybody happy? So far, so good? Now we're going to look for either side A or side B. In this situation, it doesn't matter which one you do first. In other situations, it might. We'll talk about the order in which to do things a little bit later once we've kind of run through some scenarios in which it matters one way versus another. And we'll build out a little set of directions as to like when to do what in what order. But the key here is that we know angle C and side C. So I can then set that sine of 75 over 13 equal to either sine B over B or sine A over A. It does not matter which one. For the sake of argument, I'm going to solve for angle or side A next. So there's my law of sines. Notice that I'm never going to use all three pieces together. I'm always just going to take one thing and set it equal to another one thing. Everybody's good? Okay. So this type of an equation where I have one fraction equal to another fraction is called a proportion. Do you remember how to solve a proportion from geometry? You did it a lot. This is the one where you actually want to say cross multiply. Cross multiply is a solving technique that you use to solve a proportion. It has nothing to do with multiplying fractions. So you just would have A times sine 75 equals 13 times sine 32. And then we can divide both sides by sine 75. And then it's calculator time. So let's get out our calculator. What's going to be important for me to check before I start banging away this stuff on the calculator? Since I'm about ready to use a sine, cosine, or tangent, what do I need to check? Need to make sure I'm in the correct mode. This problem should be done in degree mode because the angles are given to us in degrees. So I'll press that mode button right next to the blue second. Change to degree if I was in radian. If I was already in degree, then no big deal. And I'm going to type this into my calculator exactly as it looks like on my sheet of paper. To make the fraction, I press alpha and then y equals and then pick the first option. That'll give me the fraction bar so it can look exactly like it looks on my sheet of paper. I don't need to do it that way, but I like to take advantage of that fraction bar as much as I can because I can make sure I didn't goof any order of operations or screw up a parenthesis or something, and it will just look exactly like it looks like on my sheet of paper, which I love. And we'll press enter. So I get 713 as my value for A. Yes, Kate. I divided both sides by sine 75 to get the A by itself. Right, we're just solving for A. So cross multiplying divide is the general directions for solving a proportion, which is did my cross multiplication, then I divided. All right. And then lastly, I have to find side B. Can I just use the Pythagorean theorem to find this? I know two of the side lengths. No! Why not? It's not a right triangle. Yes. What do I have to use? Got to do the law of sines again. Just do the law of sines again. So again, I'll start with sine C over C equals, and now I'll have sine B over B. As an aside, could I have written sine A over A since I know both the angle measure for A and the side length for A? Yes. I chose not to. Why? There's a reason why I chose not to do it that way. My value for A is rounded. Are any of my values for C rounded? No. So my answer here will be a little bit more accurate than it would be if I used my rounded value for A. Will it matter to you guys? Probably not, but it's a good habit to just get into that if I don't have to use a rounded value, let's not use a rounded value. In addition, if you made a mistake in solving for side A, are you going to be able to get the right answer if you use side A? No. Side C or angle C, it would be tough to make a mistake doing that because it's just 180 minus some stuff. Everybody's cool? And to solve, exact same process as the previous one, right? We'll cross multiply. And then divide by sine 75 to get the b by itself. And then it's calculator time. So 1287. I guess these should have units on them, right? Let's go ahead and add that. But that wasn't too bad, right? Pretty easy. Now, is there a way to check this, Mr. Kulik? To check our work? Kind of. Here's the best we can do check-wise. We know that this is, use a different color. That's 75. This is 1287. And this was 713, right? What I'm going to check is to make sure that my biggest angle is opposite my biggest side, that my middle angle is opposite my middle side, and that my smallest angle is opposite my smallest side. And if that matches up, probably I'm in good shape. Is it a guaranteed check? No. But it's really fast, and if you made a big mistake, it'll catch it. Everybody feel good? So far, so good? Let's do another example. Okay. So in a triangle, if P is 43 degrees, Q is 80 degrees, or angle Q is 80 degrees, and side Q is 7.3 centimeters, solve the triangle. So what are we looking for here? We need angle R, we need side P, and we need side R. I picked R for my other angle because PQ and then R is the next letter in the alphabet there. Okay, so I'm going to draw my picture. And I'll label Everybody okay with what I've done so far? All right. What should I find first? Angle R, side P, or side R? Angle R, right? And how would I do that? Yeah, add them up and then subtract them from 180. So 180 minus 123 is 57. Okay. So I'll go ahead and draw that in then to my picture. Now, did I have to find R first? I actually didn't, because I was given an angle and a side opposite each other. So I could have found side P first. That would have been okay also. But at some point I needed angle R. I might as well do it right away first because it's so easy. All right. So I know that I'm going to be using angle Q and side Q, because those are the two that I have that are opposite each other. And doesn't matter whether I want to find angle R first or angle P, or I'm sorry, side R first or side P first. For the sake of argument, let's find side P first, because I could have done that as my very first step if I had wanted to. So again, just apply the law of sines. I'll cross multiply. And then get the P by itself, I need to divide by 1, or divide by sine 80. And it's calculator time. Again, I'm not going to bother checking the mode this time because I just made sure that I was in degree mode a few moments ago. And then I did the alpha y equals and chose the first option to make my fraction command, or fraction bar. And then I'm just going to type in like exactly the same way I see it. So I get about 506 there. I think these were centimeters. Okay. I think that's lunchtime, so we'll pick this up when we come back. All right, so before we left for lunch, we're in the middle of working on this example 2. We had already solved for angle R and side P. We have one thing left to find, and that's side R. Shh. Thanks, guys. So again, we'll be using the law of sines. I'm going to use sine Q over Q is equal to sine R over R. Again, I could have used sine P over P here instead of using sine Q over Q, but P over P uses a rounded answer, and I just assume avoid that if I can. Not wrong, but potentially a little less accurate. And again, same procedure as before, right? We're just solving for r. So cross multiply. And then we'll divide by sine 80. And at this point, it's calculator time. Again, I want to make sure that my calculator is in degree mode. I don't need to check that because I just changed it at the start of class. So I'll just do alpha y equals, pick that first fraction option, and then type it in exactly like it looks like on my sheet of paper. And there's my answer. So 6.22. And then if I want to go check, usually the easiest way to do that is plugging them in to our picture and just making sure the biggest side is opposite the biggest angle, the middle side is opposite the middle angle, and the smallest side is opposite the smallest angle, which all kind of checks out here, right? Okay. So we so let's go back to geometry for a minute. And what we want to remember here is triangle congruence. So go back to geometry. I know that was 2 years ago. And think about what you had to do to prove triangle congruence. There's like 5 or 6 theorems that you would have used to do this. They all had like a 3-letter name to them.
Oh, side.
So side was one. Mm-hmm.
Side, angle, side.
Yeah.
Angle, side.
Angle, side was one. Mm-hmm. It's angle, side, angle. And then there's a 5th one that you used on occasion that was like the hypotenuse leg. And this was a special case of SSA, where the A had to be 90 degrees. So the takeaway here is these two are law of sines situations. And really you can use the law of sines kind of willy-nilly here on these. It doesn't really matter. This SSA situation is a law of sines, but this is a slippery little bugger there. We have to be very careful if we're in an SSA situation. And these two are law of cosine situations, and we'll deal with those when we talk about the law of cosines here in a bit. So far, so good? Okay. So just to point out to you guys, let's go back and look at these triangles that we drew and just observe why they are, or which one of these situations they are. So if I look at this first triangle, I was given an angle, and then the side was not in between the two angles, right? The side that I was given is not part of both angles, right? So this is the angle, side situation. If I contrast that to the first situation we looked at, where we're given an angle, and a side, but notice there the side is part of both angles, right? So that's an angle side angle situation. Everybody's cool on telling the difference between these two? Okay. Let's look at this SSA situation then. So this is the SSA situation. We call this situation the ambiguous case because depending on the measurements of the two sides and the angle, you may have a problem that's impossible. You may have a problem that has just one set of answers, or you may have a problem that has two sets of answers. Oh dear. So let's look at how to tell what's going on. Okay? Okay, let's just say so let's just say we have our triangle here, ABC. If I have an SSA situation, I'd have something like this side, and this angle, right? Everybody's okay with that? Where the angle cannot be in between the two sides, right? Everybody's cool with that? Okay. Actually, let's say that one. Still SSA. All right. So if my angle A is not acute, then we have three situations that could be going on with AC and BC. AC could be smaller than BC, and then AC could be greater than or equal to BC. Everybody's okay with that? What do we know if angle A is 90 degrees or bigger? What can we say about that angle? It's obtuse, right? How many obtuse angles can we have in a triangle?
One.
Exactly one. So this has to be the biggest angle in our triangle, correct? What do we know about the side opposite the biggest angle? What do we have to say? What can we say about side A then? What? Has to be the longest. So could BC be less than AC or equal to AC? No, because that has to be the hypotenuse, right? So this situation just results in zero triangles. This situation is our hypotenuse leg kind of situation. Well, it's included in there, but this would result in just one triangle. Everybody's cool with that? So if you draw your picture and the biggest side isn't opposite the biggest angle, it's zero triangles possible, right? What happens if you don't know that angle A is your biggest angle? I.e., what if the angle that we're given is acute, right? We don't know it's our biggest angle. It could be still, but we don't know that. Then what can happen here? Oops, you dum-dum. There. So if you have an acute angle and the side opposite the acute angle is smaller or equal to the other side, everything is fine. You just get one triangle. If not, if the side opposite is the bigger of the two sides given, then we're in a heap of trouble here. We don't know what's going on for sure. You could get zero triangles, you could get one triangle, or you could get two triangles possible. So let's take a look at this situation in particular. And this particular situation in the SSA case is the ambiguous case, right? Because just from the given information, you don't know what's going on. All the other situations, just by looking at your givens, you know how many triangles you're going to get, either 0 or 1. But here, if we run into this situation, what's happening here? It's not always entirely clear. So here's how we're going to check. So let's look at a specific example here, and we'll show you how to check. I messed this up. What did I do here? Hold on a second. Let me pick a different color. One moment, please. Yeah, okay. My apologies. Okay. So let's look at this kind of situation. So I have an acute angle that's given. And I'm given that the opposite side is shorter than the other side. So this is the ambiguous situation. We're going to have 0, 1, or 2 triangles. Okay. The way we figure this out, which situation we're in, is we're going to just use the law of sines with what we have. And we're going to solve for sine Q. And now I'm going to compute this value. Again, need to be in degree mode. I know I already am because I checked earlier. And I get 0.984-ish. Yes. Is everybody okay with that? This number is going to tell me everything I need to know. Okay? So sine of an angle, what's the biggest possible value sine of an angle can give me? Yeah. 1, right? If you think about going around the unit circle, the biggest y coordinate on the unit circle is 1, because sine is the same as the y coordinate on our unit circle. So if this is greater than 1, we get 0 triangles. If that number is equal to exactly 1, that's our hypotenuse leg situation. That's where we have 1 triangle exactly. And if it's less than 1, we'd get 2 triangles. So in this case, we have, to answer the question of how many triangles are possible, we would say 2. Okay, let's try that again. Okay. So first thing we check is the given angle is acute. And then we have to check to see that, oh my goodness, people, what did I do here? It's cool, like you are a dumb man. Look what I did. Did I put those in the right spots at all?
No, it's just getting lost.
Yeah. I don't know what I was like, what the heck is going on here? That makes a heck of a lot more sense. All right. Now I notice that the opposite side is shorter than the other side. So this is that ambiguous case, right? Everybody's cool? All right. So again, what we do is we just set up a law of sines. So sine 74 over 2.5 equals sine of c over 4.9. We'll cross multiply and divide to get the sine c by itself. We get 1.884-ish. Now, because this is greater than 1, what can we say? No triangles.
What happens if it equals 1?
Then there's just one triangle possible. Yep. So let's look at what we would do if we actually want to solve one of these situations where there's two triangles, right? Okay. First thing I want to do is check to see the situation. The angle that we're given is acute. And then the opposite side is shorter than the other side that's given. So this is that ambiguous case. But I knew that just by the wording in the question, right? Like I know it's going to be that situation anyways. But let's just kind of confirm that. Everybody's good with that? All right. So I will start by just using my law of sines. So cross multiply, divide by sine 48. Oops. Why did I write A there? I'm supposed to write 12, dum-dum. So we're not dividing by sine 48, you dummy. Dividing by 10. That's more like it. So sine A is going to equal and let's just kind of confirm that the value what value should we be getting from this? Not over 1, under 1, because we are expecting 2 solutions here. So we should be getting a value that's less than 1 here. 0.892-ish, which is good. So that was less than 1. So we are getting 2 triangles out of this. Great. All right. So what's going to become really important here is making sure that we're kind of organizing our work. So I'm going to do a nice job of kind of separating the work that I'm about to do. So in triangle 1, I need to find angle A. I need to find angle C. And I need to find side C. In triangle 2, I also need to find angle A. I need to find angle C. And I need to find side C. But I'm going to label some subscripts so that I know which angle A I'm talking about, whether it's in triangle 1 or triangle 2, which angle C, which side C. So I'm going to put a subscript of 1 or 2 on those to remind myself, what triangle am I getting this number for? Is everybody okay with that? Okay. So we've done all of our work so far. I'm going to take this and I'm going to use this to find angle A in triangle 1. So I'm just kind of taking that work with me to there. Everybody's cool? How do I solve for angle A? If I have sine of A equals 0.892, what do I have to do to get the A by itself? No division. How do you cancel out that sine that's wrapped around the A? We did this last semester. not division, because sine isn't multiplying A. Sine's an operation operating on A.
Factor outside.
No. Yes! Good job, Lexi. We use sine inverse. So we'll do sine inverse to both sides of this equation. Everybody's remember that now? Does that ring a bell? So sine inverse cancels out sine. And how do I calculate sine inverse of 0.892? Calculator, exactly right. So second sine, and then just do the answer command to just take that value that was in there. And I get 63.10-ish. Everybody okay with that? Now, what can I do? Well, I can solve for C1 now really easily, can't I? Because I know two of the three angles. So 48 was angle B. That was given to me in the original problem. And I just found the value for angle A. So that should be 68.9. Everybody so far so good? And now to find side C, well, I'm going to use the law of sines again. Since I know angle C, I can use sine B over B to find side C. So just like now, a problem from before. So cross multiply. And then divide by sine 48. So I'll do 10 times sine of my previous answer divided by sine 48. So I get 1255. Here's the good news. The second set of answers are easier to find than the first set. Okay? Specifically, A2. Oh, are we out of time here? Okay. Remind me that we still have to pick up at this spot next time. If you guys were interested, you should be able to do certainly 1 through 10. I would hold off on 11 through 14 yet. But 1 through 10 you should certainly be able to do. Nothing is due till next Sunday. Nothing is due this weekend. Next Sunday will be our first homework check. Cool? Okay. Have a